I want to tell you a little bit of a story about Apache Beam, which is a really exciting project, which probably some of you already have heard about. It's a very ambitious project, and it's quite tough to squish it into 30 minutes, but I try my best. And also we have the office hours afterwards, and I'm welcome to demo anything or answer your questions. If you have any questions, please maybe also write them down so you don't forget them. Yeah, so my name is Max. I work on Apache Beam. I'm a committer there, and specifically on the portability aspects, which I will touch at the end of my talk. I'd like to know actually who has used Flink or Spark. Could you please raise your hand? That's quite a lot of people. And who has used Beam before or read about it, let's say? Okay, that's also a fair amount of people. And what about Google Cloud Dataflow, for instance? Okay, that's interesting. Okay, so I know you're already a bit familiar in the space. That's great. So but I want to recap for those who don't know about Beam yet. So what is the vision of Beam? It's a very ambitious vision, as I mentioned. So we have a bunch of SDKs in Beam, which basically allow you to write data processing jobs. We have Java, Python, Go, Scala, and SQL. And the way this works is that you write your pipeline, and then Beam kind of figures out a way to, using various runners, to execute your data processing pipeline on top of various backends. And these backends are like Flink, some are Google Cloud, Spark, and some others more. And so the important key to understanding Beam is that Beam sort of provides some building blocks for execution and has its own model, but it's not an execution engine. That's what the backends are for. What is the Beam way of doing things? What is the Beam model? So first of all, what is remarkable is that it's unified batch and stream model. So that means you don't have to switch to a different system or a different API if you want to use either batch or streaming. And I will show you how that actually works. It's quite a nice concept. And yeah, if you really think about streams, in terms of when you work with Beam, then streaming is sort of the default, and batch is just a bounded stream. Everything else is unbounded, right? And yeah, so in Beam you define your processing pipelines, and then obviously you apply transformation in these pipelines, and they are massively parallelizable. And so this is the concept of Beam. It's for big data, so just in case you didn't know. And yeah, and one of the other concepts that's really innovative in Beam is the concept of event time, which I will touch in a bit. There's also an excellent paper which sums this whole model up if you're into papers. Otherwise, just listen to my talk. So what does the Beam API look like? It's basically just in the beginning you set up your pipeline, which is an acyclic graph, a DAG, and this pipeline consists of transformations on P collections. So one of the things to keep in mind when you design your pipeline is that you have a P collection, you bootstrap your P collection, and you do apply on the P collection and basically supply a transform, and then you end up again with a P collection. And then in the end, you run your pipeline. So that's pretty simple. So let's start with defining our sources. Sources are actually also just transforms in Beam, which basically bootstrap from the pipeline object. Kind of wish I had brought a laser pointer, but maybe I can use my mouse? No, I can't. So here we have, in the previous slide, I showed you like this transformation from input to output. So, but you can actually have multiple, because it's a DAG, you can have parallel sources as here, like we have an input 1 where we read from a text file. Then we have this in-memory kind of string collection there. And you can also read to Kafka, and there are a bunch of adapters. You can check it out on the homepage. That is covered. And then really, if you want to understand transformations with Apache Beam, you have to pretty much only understand two main concepts. And if you come from MapReduce Hadoop world, those of you who do, then you know probably like the MapReduce phase and the shuffle in between. And that's pretty much what, so the MapReduce part is basically what the pardo is, the parallel do. So it takes an input element and transforms it into an output element. So just a simple example here, we have these strings given, and we basically transform them into key value pairs where we assign a word count of 1. So this is the famous word count example. That's basically your map phase, and then you do the group by, which shuffles the data and groups all the same keys together with their values. So then you could actually now do a pardo again and reduce these to sum up the number of word occurrences. Yeah. So that's pretty much, I mean, if you know these two, then you can pretty much build your pipelines very, very flexible. So how does that look in practice? So I'm using Java here for these examples. I hope that doesn't scare you too much. So we have our words here loaded, and if we want to assign the word counts, as I showed you on the previous slide, we have these pardo transform, and the pardo gets a do event function. You can see it takes it from string to key value of string integer. And yeah, and then you have the process element function, which is called for every element. And for the group by key, it's basically as simple as just doing this group by key create transformation, which will then give you, for every key, it will give you, which for every word, it will give you an iterable, so basically a list of integers, which you can then sum up. And that's basically, in terms of primitive transforms, all you need to know for the beginning. So you can build some more cool stuff with this. And one of the things in Beam that is also used heavily is combine, but it's actually just composed of these pardo and group by key transformations that I just showed you. So combine, for example, it basically is like a shuffle and reduce in one step. So if you already have your key value pairs, your words and your word occurrences, then the combine per key basically gives you automatically groups and gives you, you can supply a function to sum up the results per key. And you can even do this whole like map shuffle reduce in one step if you define like a combine fn, which gives you even more flexibility. Yeah. And I realized this has been already a lot of code on the slide, so I don't want to give you more for now. And there are more transforms like co-group by key, which is basically a join. So you take two inputs and merge them, and then you can do joins of all kinds of sorts. There's also flatten, which is basically like a union. There's a special partition transformation, and also you can define your own. That's the beauty of the model. There are even more advanced concepts like side inputs, which is basically gives you a way to pre-compute a data set that you receive in your operator before that operator starts processing data. So that's really useful if you if you want to provide a machine learning model, for instance, or some like static input that you know that you can compute it up front and have that available everywhere. And yeah, multiple outputs might be useful if you want to diverge your computation afterwards. They also state in timers. I'm not going to go into this for now. So you might be wondering now, didn't he say in the beginning that Beam was about like unbounded data and streams, and all we did was like MapReduce? That's like, I mean, that's not going to work for streams if we have infinite input. Actually, yes, that's true. But since streams are unbounded by nature, we have to have some kind of discretization of the stream. And this is done in so-called windows. And these windows basically do a grouping in terms of some criteria. Most of the time, it is actually according to time, because this is what we're usually interested in, but it's quite flexible. And then, because you can find your own window function. And then there are triggers which basically decide when a window is complete or when results from the window should be emitted. And one of the really cool new things that Beam brought was event time. Because time is very important when you process data, and usually you have some sort of timestamp assigned to your data, but maybe it's not explicit, or you assume the timestamp is the time when your data arrives or so. But in Beam, like, this timestamp is explicitly represented in every element. And if you have a batch pipeline, for example, then it might be just like a default timestamp or so, and you don't have to take care of it. And then there's this other cool concept which is called the watermark. The watermark is basically a timestamp that is passed through the entire DAG, and it indicates the current event time. And again, most of the time you don't need to worry about it, but it's a really cool way to be able to set the time basically in the computation. So I realize this is not clear to everyone, and I want to differentiate event time from processing time, first of all. So imagine this is like a computation, and in that computation you have some notion of processing time, which so this could be your clock on your machine which you run, and that processing time basically passes from 0 to 60 minutes, and you have events arriving, and they have an event time, which is on the y-axis. So a lot of times we assume that event and processing time are the same, and that's like for the first three red dots we have same, like 0, 5, and 10, the same processing and event time. But in reality, what happens is that you do some kind of computation, and you for example, you sum up user scores or so for every 10 minutes or so, and you just take what comes in, right, and sum that up. But it could be actually that you are thinking you're at processing time 20, but actually your event time is 10. So that would actually mean we would be late in processing that data. And similarly, it could also happen the other way around. And Beam just gives you a means to give credit to that time distinction, and that's really cool. So for those who have maybe not understood this yet, here's a nice analogy. So if you think of Star Wars, and for those of you who know Star Wars, know probably also that the episodes from the storyline didn't appear in the chronological order. So first there was like 4, 5, 6, and then 1, 2, 3, and that's well, if you want to watch it from the beginning to the end, the story, that's kind of out of order, right? But it makes sense because that's just when the episodes appeared, right? So you can think about it like this. So processing time would be the appearance as we know it of Star Wars, and event time would be the episodes sorted like chronological to the time in the movies, actually. So with that knowledge now, let's apply our our knowledge about transformations and time and windows, and built like a more interesting but still simple pipeline. So I'm assuming I have some input, and I want to sum up scores or some kind of integers on that input. And yeah, I'm doing it per key, so it could be user and the score for a game, for instance. And yeah, the way we typically, what helps when you develop pipelines and you want to leverage the full power of Beam is that you ask yourself these 4 questions. So what are you trying to compute? Well, I'm trying to sum up integers per key, makes sense. Then when actually, where are you doing that in event time? So here I'm defining just in front of the actual summation, I'm defining windows of 2-minute intervals. And these are fixed windows. So they're different kind of windows. If you don't do any windowing, it's a global window, which you would use for batch. And then there's the fixed, the sliding, and the per session window. And well, these are pretty much, I mean, they're self-explanatory, but the fixed ones, basically, they create a new window every 2 minutes. And the sliding one basically has a size, but also it has a sliding interval where it moves like continuously, so the windows are overlapping per key. And the way to think about it is not that there's a window, and then there's another window, and then there's another window. No, these can actually exist all at the same time, depending on what kind of data arrives. Like I showed you in the previous, like here in the, if we have some element that is late, then this might actually end up in a later window. But then the question is, of course, we have all these windows. We have to do the actual computation and emit some results, right? And this is where triggers come in. So the default trigger, if you don't specify anything, is actually this trigger at Watermark. So the Watermark, I told you, is like a timestamp that is passed from the sources to the sinks in the pipeline. And the Watermarks basically advances the event time, but it also gives some flexibility of how fast, how quickly time advances. And most of the time, this is actually based on a heuristic, because you can never be sure whether, like, I mean, whether data arrives late or not. But it gives you much better control of your computation. So yeah. And there are also other kind of triggers, so not only event time, you can also do it processing time based or based on data that arrives. Yeah, and so I mentioned early and late, so there's a possibility also to fire earlier. So in case you want really early results already, even though the window is not yet at the default trigger at the Watermark, or even if you have something late arriving, then you might want to fire again when something arrives. And by default, Beam throws away the entire window after it has computed the result. But it is also possible to actually hold on to that window. So you can do like an accumulating fired panes, which will then give you the possibility to basically recompute the entire result, because you still have all the data when something arrives late. So I mentioned that we have actually also other SDKs and not only Java. And I think that's really exciting, because it gives also people who don't feel so comfortable with Java a chance to play around with Beam. And if you compare the two APIs that we have available here on the slide, you see it's actually quite similar. I mean, the syntax here with the pipe, it's maybe not exactly Pythonic, but it is kind of like similar to what you would get in a shell, and that's kind of cool. But otherwise, you see the concepts are the same. So I'm sticking now to Python, and I want to execute now this pipeline. So what I do is basically I take one of the runners, like the Flink or the Spark runner, and I say like run pipeline. So yeah, that's basically it. So what runners are actually out there? So there is a way to directly execute your pipeline for local testing. For that we have the direct runner. And yeah, then there's Apache Flink, Apache Spark, Samza, Apex, and you can also run on top of the Google Cloud. And there are a bunch of others work in progress, and I hope we will even support more runners. On the website, there is actually a compatibility matrix where you can see which feature sets are supported by each runner. So, I mean, the Flink runner is actually pretty much on par with the Google Cloud and supports the whole model feature set, but not all of the other runners do that. So that's something, it's a consideration to take into account. So actually, I haven't told you the whole truth. So so we have multiple runners, and we have these different SDKs, but the vision was always to support multiple SDKs, right? But the reality was that up until sort of like a year ago, basically only Java pipelines worked because we had to figure out a way to execute with all these different SDKs, right? Because all of these SDKs can have like Python code in the language of the SDK, and how can we execute that with Java, right? I mean, sure, we can spin off a Python like process inside a Java function, but this gets really tricky, like when we have libraries of that sort, and when we want to have like a proper environment that is not, that is consistently there, and we don't have to bring up every time. So what can we do? It's simple, right? We have n runners, we have m languages, so we just build like n times m translation path, right? So we have 5 runners, for instance, 3 languages, 15 translation paths. No problem, right? Well, it's a bit of a problem actually, because replicating this logic for all these different languages and runners is a lot of work. So, what the project did instead was work on portability. And what portability means, and that is basically like the last missing piece of Beam, which is already like very far, and actually for the Flink Runner, it's now a supported feature. But this is very exciting, and because it gives you the opportunity to use any of the supported SDKs, and including libraries and user-defined function, and write a Beam pipeline with it. So to do that, we actually had to find some language-independent way to express pipelines, and that is called the Runner API. The Runner API has basically transformations from the pipeline, which the backends, which are maybe in Java, these are all in Java actually, they can understand these concepts fairly easily. But then there are also these bits like in the pardo function where we have Python code or Go code, and the Java backends really don't know what to do with that. So we have the FN, the Fun API, which is basically an abstraction to execute these parts which the backends don't understand. So just to illustrate this a bit more, so we have, without the portability, we had basically like SDK and runner all in the same language, and then we had these tasks running in the backend, and they are all like tied to a single language. With the portability, it's a little bit more complicated, but it works really elegantly. So we have the SDK in a language of our choice. Then we actually have the job API, which manages the whole job submission to the cluster. So in the past, you had to kind of know whether you're using Spark or Flink. You had to, use their way of submitting stuff to the cluster. But now there is a Beam job server, which takes your Beam pipeline. And because it's in this runner API, the runner can then go ahead and submit this job to the backend. And whenever the backend sees like stuff in the pipeline that it doesn't understand, for example, a Python function, then it brings up like a Python container, which we call the SDK harness, and sends data to that container. The container processes it and sends it back to the backend. So and that works for all kinds of transformations in Beam, including side input and state. So that's a really elegant way to solve this. So we don't need to have this runners times SDK, all these execution paths. We just need to implement the SDKs, which we already have. We need the runners to be able to support these portable jobs. And then we need to also, only once for each language, we need to implement these SDK harnesses. So I mentioned the Flink Runner is like the first open source runner which supports this new way of execution. This doesn't mean you cannot try out Beam today with another backend. It's just that we are sort of in this transition phase where we have the old Java way of executing in the open source, and then the potentially also cross-language portable way of executing jobs. So, and that's really exciting if I think about it, that we will be able to execute also Python and Java Beam pipelines in the same like job. So that's potentially a use case, a future use case. There's some overhead to it, of course, because we have to send data to these containers, which involves some like serialization. We did some measurement, and it was between like 5 and 10% overhead. But actually, it could also be zero. It really depends on your pipeline. I think it's definitely worth the trade-off. That said, there will also be a way to still directly execute, like for example, a pure Java pipeline for people who really want to leverage like all the performance and not go through that portable way. Yeah. So I was gonna show you a demo, but I feel like if I try to set this up now, I probably run into a time problem, and I would like to defer this to the office hours, unless somebody really wants to see this running. You have to take my word for it for now. So, how can you get involved, or if you want to learn more about Beam? So the website, of course, is great because it has really good documentation and examples how to write Beam pipelines. Then there are also these mailing lists, and I'm on these. And if you write an email, you can be sure to receive some response from all the committers and other users. And there's also a great Slack channel, which maybe you get even a faster response. You can follow Apache Beam on Twitter. You can follow me on Twitter with this weird handle, Stadtlegende. And that's it. Thank you.
Hi. Can you say a little bit more about how the Watermark heuristic works?
Yeah, so let me go back to, in your sources, when you read, for example, from Kafka or PubSub or whatever, there's a way to emit watermarks, and a lot of sources, they take, for example, the last elements in the last minute, and they emit the minimum, for example, of the timestamp that they've seen so far. So that way they make sure that they don't advance the watermark too quickly. So because if there's a timestamp which is much later already than in time, then the watermark would be moved too far forward in time, and then new elements might be considered late. So this is one option that sources use. Also, other sources, they use just the processing time, which is also an option. And yeah, I think these are the most common two ways of emitting watermarks. Yeah, the watermark basically tracks the real time, whatever you consider real time. It doesn't have to be necessarily the time on your machine, but it's basically, I mean, it needs to make progress. If it doesn't make progress, then basically execution halts, and nothing is computed anymore. But it's possible, as you can see here, that it is temporarily sort of lagging behind and then catching up again.